Gentlemen, so far we have these two thermometers, a digital and this little cheap one we have. We boiled water and we checked the validity to make sure that these were actually theoretical values. So this one came within 1 degree, even less, but we're going to say 1 degree off. And this one was within like 5 to 6 degrees.
Is it Fahrenheit?
Yeah.
No, less than that.
It was more like 3 or 4.
About 3 degrees
Okay.
off. What about 3 degrees over?
Did the same thing with ice too.
We did ice water, and we had to make sure that the thermometer was actually in amidst the ice, not below it.
Right.
Because the water below it had output out the sides, and the melting ice took longer to drop, like the cold water from the ice. So we just put the tip in the ice water right
We went
with the
ahead
ice.
and worked on the manometer process here and here in case we need another one for the middle.
We put epoxy around some holes with our taps on, so we can plug a pipe up, and now we have a manometer if we need to work that. Problem with our manometer tube is it's very thin and narrow, and the water doesn't have the ability to level off evenly. So, with that respect, we were able to calculate that the max distance was about 3/8 inch. We're going to verify that, record it, and make sure our calculations reflect that.
Right.
So, what else?
Secondly, we're talking about, instead of doing one whole system where it goes underground and goes in the coil, we're going to do one system where it's underground and then measure the difference between that and the coil, because we want to isolate, we want to find out where the heat's actually going. In a series like that, it just makes it a lot more difficult to understand where heat's going.
Now, if we did it in a single system, like we were originally planning, we realized it would become a multivariable problem. We would have an equation for the ground, and then we'd have an equation for the coil. And we don't understand the equation for the coil well enough at all to be able to combine them together and understand what's really going on. So, and on top of that, we have too many variables that we don't quite understand yet. The sun, humidity, wind speed, things like this. The only wind speed we're actually dealing with is in the pipe. We have another wind speed outside the pipe that we don't know what's going on yet. We can visualize it, but we can't plug the equation yet. So, as Pete was explaining, we're going to cut the pipe in half. So we have one problem dealing with underground, one problem with the coil. Are we cutting it in half, or are we using a single pipe?
We use the same one.
We're going to use the same pipe.
That way there's more heat transfer. Anyways, we're going to take data today at our atmospheric temperatures and all of our conditions, and then we'll do it again like maybe next weekend with you guys and see what the change is depending on what the atmospheric conditions are. And that way we'll all be involved with this project.
All right, so this is just a recap of what we've done so far, where we're going today. Guys, I hope you watch this. Just pay attention, get an idea of what we're doing, get on the page with us. We really appreciate it. This is where we come together. You aren't lost. And, so all right, cool. Great.
All right, so yeah, also if y'all think of anything that we may have looked over or haven't done it, or anything, just if you don't understand it, we'll try to explain it to the best. Oh, we're also going to conglomerate all this video and make a little thing for him to watch. So, yeah.